calculator has this function built into it. It is called the numerical derivative function on here. Numerical derivative. Looking at something numerically means using tables or values, not using algebra, not using a graph. If you're using a TI calculator, they call it, the shorthand is N-deriv, for numerical derivative, obviously. The numbers you have to put in here, I will show you where it is. I'll show you on both calculators because, again, if you have, it might look slightly different on a, it looks more like you write it on a TI-84 if you have it, I don't know, updated to the latest whatever operating system. It's under math. It's down at the bottom. Or again, you could be tricky and go push number 8. It's 8th in the list. What you have to put in is the function. What's the function we're using? X cubed. Or you could put x, right? This is not obvious why you have to do this, but you have to tell it what the variable is. So it's function variable. I know that if you look at x cubed and someone says what's a variable, it's pretty obvious, but this is a calculator. Nothing's obvious to the calculator. You have to put the function, the variable, and what else do you think you have to put in there? 2, the value you want, right? You got to put in 2. You do have an option of putting in how big you want the h value to be. The default h value is 0.0001. So normally you don't have to enter it. If you wanted more precision, you could put in a smaller h value. You could put 0.0000, a whole bunch of zeros. If it's a complex function, it might take longer. But you can put in the h value if you want. I am not going to this time. So that's with the default h value of 0.001. I can't remember if it's default to 0.001 or 0001. If you put in I don't know why you'd want to do this, but if you put in a smaller h value, 0.1, oops, that's not 0.1. There's 0.1. It's going to be less accurate. If we put it, what was the first h value we used when we calculated it by hand? 1, right? It's going to give us that value of 13. This is just doing exactly what we did there. It's picking a point on either side and finding the slope. On this other calculator, if you have an 84 and it's more recent operating system, which you can update if you want, numerical derivative, it looks different, but it looks like the way you would write it. Okay? This is how you'd write it. You'd say the derivative with respect to x of x cubed. Okay, derivative with respect to x of x cubed evaluated at 2. I don't know if you could put comma 0.0001 or whatever. Maybe you can. That's the way you'd write it. You wouldn't write n-deriv because that's just calculator syntax. Even if you're using the calculator, it's still better to use the actual notation here. Gives you the same thing. We could try this and see if it actually allows you to put a comma. Let me try this. It doesn't like that. So maybe the older one is better. Maybe there's a way to do that. I don't know. Anyways, either way, that's what that numerical derivative function does. It calculates the derivative based on just finding the slope. You have to understand what your function looks like. Because if you calculate the slope, remember what absolute value looks like? What does absolute value function look like? It just looks like, it looks like that and that, right? What's the derivative at 0? There is no derivative, right? Does not exist. If you get the calculator to figure it out, what's the calculator going to come up with? Why is it going to come up with 0? Whoever said that. Because it's true. It is going to come up with 0. Why is it going to come up with 0?
Point on each side.
Yeah, a point on each side. It's going to go that way. It's going to go that way. it's going to say, look, it must be 0, right? So you have to kind of just think about what it's giving you, right? The calculator is going to give you 0, even though it's not 0. It doesn't exist. If you try to differentiate it at a non-differentiable point, it'll still give you a value. So you need to know it's differentiable in the first place. I want you to try this question. You can just use the values, and then if you wanted to check it after with that numerical derivative, except you don't know the function here. If you don't know really you would use this if you don't actually have the function. If you had the function, you can do it using algebra, right? If you don't have the function, you can estimate the derivative at 1. What's your only option here? If all you know is a table of values? If you want to know the derivative at 1, how can you estimate it? Yeah, just use that point and that point on either side. There's nothing else you can do if you don't know the actual function. If you want the derivative at an end point, well, you would say, well, I'll use this point and the one on this side, but I don't have a point on this side, so what's your only option then? Can you use a symmetric thing if you're missing a point here? No, right? Then you have to use just between these two, which might be a little bit too high or low, depending on the way the graph goes. You might want to plot the points here first before figuring out the slopes. I don't need you to do every single one of those.